Hey everyone, in this video we're going to be starting our next chapter and we're going to be talking about things called probability distributions. So today we're going to define, really there's two major types of probability distributions. We're going to go over how to recognize which is which and just a general introduction to what a probability distribution is. So first thing that we're going to start with is called a random variable. A random variable concept is a little bit confusing, but it's just basically any value that x is just our variable. Don't think of this like the algebra type of variable. It's a little bit different than an algebra variable, but it's a value that x can take on in a given experiment or observation, given that the outcomes of this experiment or observation are random. For instance, let's have an example here. Let's say we're going to, our experiment is going to be to flip a coin and count the number of heads. Okay, so that's our experiment. This is a random experiment, right? You're going to flip a coin. That's a random activity. And counting the number of heads, that's going to be what you're going to be measuring. So the random variable is the value that x takes on. So the possibilities for x meaning the number of heads, that is our random variable, because that is what we're measuring and it is a random occurrence. So the values that this could take on, x, and we're going to make these little tables kind of like this here. So if we're going to roll it, let's say 10 times, well, we could get 0 heads, could get 1, could get 2, could get 3, could get 4, could get 5, could get 6, could get 7, could get 8, could get 9, or could get 10 in this experiment. So the random variable x is the number of possible heads. In this probability distribution, we're also going to have some probability of x occurring. So let's say we flip this thing and we're going to do this experiment a bunch of different times. We're going to do 10 coin flips again and again and again. And we come up with all these different probabilities. So what's the probability of getting exactly 0 heads? That's going to be very low. Actually be 1/2 to the 10th power. So I don't know, maybe this is 0.01. And then by getting 1 is, let's see, 0.05. So we got all these different probabilities. And when we add these up, the sum of these should be 1, which we'll talk about in a little bit. But basically, note that a random variable is all the possibilities. So this is the random variable, the number of heads. Another example, let's say you're going to measure all of the heights, measure the heights of all students in the class. So all the different possible heights, so x would equal the height of each student. So that would be the random variable. And then you would list out all the heights and then the probability of the heights and so on and so forth. Now these are two different types of random variables. The first one is something called a discrete random variable. Discrete, and this one is something called a continuous random variable. So those are our two types, discrete or continuous. That's what we're going to define next. So a discrete random variable can only take on, say, finite or countable. That's the key word here is countable. Countable values, usually they're whole numbers. So examples of discrete random variables, well, number of heads flipped. Okay. Because you couldn't have 2.5 heads, right? You couldn't have 2.3 heads. You couldn't have 7 1/4 heads. It's usually a whole number. It's not always a whole number, but it's usually a whole number. So number of heads flipped. That would be an example. Let's say the number of siblings that each person has. Could be really anything that you're counting, number of fingers and toes that you have, anything that you're, again, just counting. Let's see, how many days of school? Days of school in the year. Something you can count. Okay, so anything that you can count is what we call a discrete random variable. It is countable. The opposite of that is something called a continuous random variable. A continuous random variable can take on any of the countless numbers of values on a line interval, meaning it could be 7, or it could be 7.1, or it could be 7.25, could be 7.99, could take on any value on a line interval. So typically when we think of continuous, you want to think of this one word. It's not in the definition, but I would write this down. Measurable. Continuous is measurable. Typically these are things like height, because someone's not going to be exactly, 5 foot, 10 inches or whatever. They could be 5 foot, 10.25 inches, right? Or someone's not just going to jump from 5 foot to 6 foot to 7 foot to 8 foot. There's an infinite amount of values that you could have people be between 5 foot and 6 foot. You could be 5 foot 1 and 7/8, or you could be 5 foot 3 and 2/5, whatever. So things like height, something that you measure, weight. You could be exactly, 170 pounds, or you could be 170.2 pounds, right? There's an infinite number on an interval. If you think of this sort of just like a line interval, infinite number of possibilities. We also measure distance. So if you live, chances are you probably don't live exactly exactly 8 miles from school. You probably live like 8.1 miles from school, right? So anything that can take on decimal values. Any measurement of time would typically be a continuous random variable as well. So things that you can measure. If you measure it, it's continuous. If you count it, it is discrete. We'll have lots of practice over that. So, when we get into graphing these, don't worry about this so much right now, but discrete would kind of appear as just like dots when we were graphing them. Kind of like a scatter plot, if you will. And continuous would actually be these lines. So it would be continuous lines. We will get into those in future sections of this chapter, but that's kind of the difference you can see as well. So we're just going to go through some examples real quick. If you were to measure the time it takes a student select at random to register for the fall term, this discrete is continuous. Well, it's measure, that's a keyword, and it's time, so that means it's going to be continuous. Count the number of checks deposited at Huntington Bank on a random day. Well, you can't have like 2.3 checks. It's either going to be 2 checks or 3 checks, or 200 or 500 checks. This is something that you would count, so that is discrete. Oops. All right. Measure the amount of gas needed to drive your car to California. The keyword there is measure. But even if that wasn't there, if it was just the amount of gas needed to drive your car to California, well, you might need, 200 gallons, or you might need 201.7 gallons, right? It could take on an infinite number of values in between. It's not necessarily going to be exactly 200 gallons of gas or whatever it would be. So it's measuring, it is continuous. Pick a random sample of 50 CTEC seniors and ask them if they voted. Think about the results of that. Let's say it's 23 that voted. You're not going to have 23.7 people that voted, right? So they're going to be 23 or 24 or 25. It's going to be whole numbers, something that you could count. So this is discrete. Just a few more examples here. The volume in a sphere. So think about if this is something that you would count. Will you count the volume or you measure the volume? Will you measure? Remember, continuous is measurable. Discrete is countable. So measuring, you measure the volume, right? So that would be continuous. A gallon of water. This one, this is, you would measure it as well, right? You would measure out a gallon of water. That'd be continuous. Molecules of water, that's a little bit trickier. This one would be discrete because you'd count the number of molecules of water. And that's a little bit challenging, but the ones in your book aren't quite this challenging. Acceleration of a car as it goes from 0 to 60. You would measure how fast this car is going, right? And it is a continuous number line. So that would be continuous. Changing shape of a balloon as being inflated. So as this balloon is inflated, you would measure how the shape is changing, right? That was growing, like the volume is increasing. So you would measure that to be continuous. The height is something that you measure as well. So that would be continuous. The number of years, so number is something that you count. You count 5 ears of corn or 7,000, right? So it's discrete. Number of green M&Ms, well, you would count that. And again, assuming there's none like broken in half or whatever, it'd be a whole number. The time it takes for a car battery to die, that is something that you would measure. So that would be continuous. All right. So remember, if it's continuous, something that you measure. If it is discrete, that's something that you count the number of them. Get a couple of these examples, maybe aren't amazing, but you'll get the hang of it. All right, one last thing is we're just going to briefly delve into what a discrete probability distribution is. So if I were looking at the number of heads, if I were to draw that little chart that I drew, the key thing with this, there is just one problem in your assignment that you have to do this. Let's say a number of heads, 0, 1, 2, or 3 heads. And the probability of these associated random variables here, if you had a little probability chart that looked like this, when you add the sum of these probabilities, so let's say this is 0.2, this is 0.15, this is let's say 0.3, and this ends up being 0.35. All right, based on your results, the sum of these always would have to equal what? And that is the sum of any probabilities always has to equal 1. So when you add up the probabilities for any experiment, it has to be a sum of 1. I mean, if it's not, that means you missed something at some point. So you just have one problem where you have to look at this and determine if it's a valid probability distribution. Basically, you just need to determine if the sum of the probabilities equals 1, sum equal 1, question mark. And in this case, you would have 0.2 plus 0.15 plus 0.3 plus 0.35. And that would equal 1. So this would be, yes, a valid probability distribution. If you had a similar thing here, and these did not sum to equal 1, it would not be a valid probability distribution. So if any of these, you add up all of these and they don't equal 1, then it would not be a valid probability distribution. So in this one, this would be 0.7. This is be like 0.86. So this would be no. So that's just the last thing. We'll talk about that more probably in the next video. We'll actually look at these probability distributions. But for now, you just need to know, is this a valid probability distribution or not? All right, so that is it. Good luck with those, and reach out to me if you have questions.